Today we will see how to evaluate the integral 1 over 12 cosine 2x plus 5 sine 2x plus 13 using the substitution u equals tangent x. Well, because of the nature of the constant term, which is 13, the given substitution is actually not required. However, this is a question found in one of the most competitive university entrance exams in the entire world, and in that exam they have asked the students to use the substitution u equals tangent x. In fact, that substitution is a universal method to solve these kinds of problems. That is because we know using the tangent x we can easily write down cosine 2x and also sine 2x. Not only those two terms, you can use tangent x to write down tangent 2x as well. So what are those three expansions for cosine 2x, sine 2x and tangent 2x in terms of tangent x? Let's look at those three first, and then we can start solving this problem. We know cosine 2x is equal to 1 minus tangent squared x divided by 1 plus tangent squared x. Since tangent x is given as u, we can write it down as 1 minus u squared divided by 1 plus u squared. Similarly, sine 2x is equal to 2 tangent x divided by 1 plus tangent squared x. Since tangent x is equal to u, we can write it down as 2u divided by 1 plus u squared. Similarly, tangent 2x. Tangent 2x is equal to 2 tangent x divided by 1 minus tangent squared x. Since tangent x is equal to u, we can write tangent 2x as 2u divided by 1 minus u squared. This identity right here for tangent 2x is very popular. Almost everybody knows that. However, you may not know these two identities, sine 2x and cosine 2x, using tangent x. In case if you need help deriving those two or even tangent 2x, please feel free to let me know. I will make another video explaining how to derive these trig identities. Now the given substitution is u equals tangent x, which means I need to differentiate both sides of this. Then I get du being equal to secant squared x dx. We know that secant squared x is equal to 1 plus tangent squared x, which is the second of the three Pythagorean identities from trig. Since tangent x is equal to u, we can write this equation as du being equal to 1 plus u squared times dx. Then divide both sides by 1 plus u squared, we get du over 1 plus u squared equals dx. Alright, now we can substitute those things in the given integral. The given integral is integration 1 over 12 cosine 2x plus 5 sine 2x plus 13 dx. We are going to write it using these substitutions. Integration 1 over the denominator, I will write it inside brackets. That means I'm going to assume we have brackets for the entire denominator. I will open brackets. The first term is 12 cosine 2x. 12, we know cosine 2x is equal to 1 minus u squared over 1 plus u squared. So let me write it as that. 12 times 1 minus u squared over 1 plus u squared. And then I have plus 5 times sine 2x. Sine 2x is equal to all of these. 2u divided by 1 plus u squared. And then I have a plus 13. All of these are in the denominator, and then I need to close brackets. And then I have dx. We know dx is equal to du over 1 plus u squared. Alright, now we can do some simplifications. For the simplification, I need to distribute 1 plus u squared term into each of these three terms inside brackets in the denominator. When I do so, this integral becomes integration 1 over, when I multiply 1 plus u squared times the first term right here, since that term also has 1 plus u squared in the denominator, 1 plus u squareds will be cancelled. Therefore, I'm only left with 12 times 1 minus u squared. The second term also has 1 plus u squared as a denominator. Therefore, those 1 plus u squareds will be cancelled, and I'm only left with 5 times 2u, which is 10u. And then I have to multiply 1 plus u squared with the 13 right here, plus 13 times 1 plus u squared. And then I have the du term right here. Let me write it as just du. Alright. Now we can combine some like terms from the denominator and simplify it some more. I have integration 1 over, I need to distribute 12 into these two and 13 into these two. Then I have negative 12u squared and a positive 13u squared. Those two will be simplified to become 1u squared. And then I have 10u from the middle. Let me write it down next. And then I will look at the constant term. 12 times 1 is 12 and 13 times 1 is 13. Those two will be added to become 25. And I have a du term. Alright. Now we know how to integrate 1 over quadratic forms. We discussed such integrals during the last week. For those who need help on that section, I'll have the link posted down below in the description. I'm going to directly apply the knowledge from that section right here without too much of details. Alright, we can see that all of this denominator can be written as a complete square. So let me go ahead and do that. This integral is going to be equal to integration 1 over u plus 5 everything squared du. Then we know that we can use the result from the standard table. We know integration ax plus b raised to the nth power dx is equal to ax plus b raised to the n plus first power divided by a times n plus 1, where n is not equal to negative 1. If you pay attention on this integral again, we can rewrite this as integration u plus 5 raised to the negative second power du. By directly applying the result from the standard table, we know the answer should be u plus 5 raised to the negative 2 plus 1, which is negative 1, divided by negative 1 times the coefficient a is also equal to 1. However, this is an indefinite integral, therefore I need to add a plus c, where c is an arbitrary constant. I will write it as negative 1 over u plus 5 plus c. In fact, this is also not the final answer because the original question was given in terms of x. Therefore, the final answer should also be ideally given in terms of x, even though the u was defined in the question itself. U was equal to tangent x. Therefore, our final answer should be negative 1 over tangent x plus 5 plus c. Alright, that's a complete answer for this example. If you would like to try a homework question, I would like to give you one. Here's a homework question for you. Evaluate the integration 1 over 4 cosine 2x plus 3 sine 2x plus 5 dx. That's your first homework question. Try to evaluate this integral using the method discussed in this video. My second homework question is try to evaluate this same integral using an alternative approach, which means without using the substitution u equals tangent x to solve this problem. In fact, in my next video, I will show you how to evaluate the integral discussed in this video without using the substitution u equals tangent x. Alright, I hope you enjoyed this video. Thank you so much.